All right, today we're doing math practices and problem solving, lesson 16-4, constructing arguments. I can construct arguments about geometric figures. Alfie thinks that if he cuts a parallelogram along a diagonal, he will get two triangles that have the same shape and size. Is he correct? So you can get two triangles that have the same size if you cut a square on the diagonal. But if you cut a parallelogram on a diagonal, you're not always going to get two triangles of the same size. So if you're going to cut the parallelogram has to be a square for it to work, where all sides are the same length. This one isn't a really good example here. Let me get something that looks a little more rectangular. See, now you can see that these two sides would not be equal. On this one, they would be. On this one, they would be, but not on that one. So you want to be able to say, if I cut a square, I can get two triangles with the same size. If I cut a different kind of shape of a parallelogram, I have to have the sides all be the same length to get the same shape. So that's constructing an argument, and we'll move on. I'll show you what I mean the next page. So how can you construct an argument? Anika says if I draw a diagonal in a parallelogram, I will always form two right triangles. Is she correct? Construct a math argument to justify your answer. What do I need to solve the problem? So what you need to do is you need to examine several cases. Just like when we were looking at tables and we were trying to figure out what the rule was, and I would tell you, make sure that you don't just check the first pair of numbers, check that your rule works for all pairs of numbers. The same goes with constructing arguments for geometry. It might work for one shape, but try several other shapes that fit into the same category. So you need to examine several cases, including special cases, and then you can state your conclusion. Then you can make an all or nothing kind of a statement. Anika is incorrect. The triangles are right triangles only when the parallelogram is a rectangle or a square. So in this case here, when you're using a parallelogram and your rectangles and squares have four right angles. So each triangle formed by drawing a diagonal will have a right angle. That's correct. They'll both have the same angle there. But if the parallelogram does not have right angles, each triangle will not have a right angle. So we're good with rectangles and we're good with squares, but we're not good with parallelograms that do not have right angles. That will not work when you do the diagonal. So that's trying using several different cases. So let's see if we move on a little bit here. Next page. So Jamal says two equilateral triangles that are the same size can be joined to make a rhombus. And what is the definition of an equilateral triangle? We want to start with that. So an equilateral triangle is going to have all sides, an equilateral triangle, all sides same length. And the definition of a rhombus is a parallelogram with all sides the same length. So let's get that out of the way first so we understand what we're talking about. How could knowing these definitions help you construct your argument? So knowing the definitions are going to help you support your argument. So now when we go down, is Jamal correct? We can say yes. All sides of an equilateral triangle are the same length. So when the triangles are joined, and you could try this on a piece of paper. The quadrilateral that you make will have sides the same length. And we actually do have in our toolbox, we do have some tools that can you can mess around with the shapes in your uh, Savvis toolbox. So let me see if I can pull that up for you. There, it's in your Savvis toolbox. So let me pull up. Here we go. If we go into our tools, oops, that one. And try to find my tools here. Student Edition, Interactive, listen and look. Well, I know I can get my tools in here, so let me hop into my Practice Buddy. So I know I can get my math tools by going into my Practice Buddy. And I can look at my shapes, my geometry, and I can take my shape, my equilateral triangle, bring him over here, bring another one over here, and I'm going to rotate him around and smash him up. All right. You guys are better at this than I am. There we go. So there we go. So we've got we can prove it by using a drawing as well. There you go.